Hey all, today we're going to continue to talk about probability rules, in this case, a conditional probability. So we've talked about some general rules of probability, and we've talked about the addition rule, and now we're talking about what happens if we set a condition for our probability. So some notation here, of course, this is the probability notation still, and this little bar here represents the word given. So this represents the probability that event B happens given event A has already happened. So that is like setting a condition. And in order to find that probability, we find the probability that they both happen at the same time. That's an AND probability, which we've spoken about. And then we divide that by the probability that event A happens. This is one that's on the formula sheet. Um, this is one that probably will be clearer once we do a problem right now, but it's good to have this formula and to use it often. So if we go back to our problem that we used in the last lesson, when we're talking about students who live on campus and students who have meal programs, and then of course some students do both, we want to know if you're in a facility, a dining facility, where you are required to have a meal plan to be in, what's the probability that a student you meet and enjoy their company, what's the probability that that person lives on campus? So first we're going to set up our formula. I want to know the probability that somebody lives on campus given they are eating in a campus dining hall. So I need the probability that they do both. And then I'm going to divide by the probability that they have a meal program. Remember, E stands for eating on campus, meal program. One of the ways that I like to remember this is that this condition, the event that's already happened. So we already know this person has a meal program because they're in this dining hall. That event shows up 3 times. It shows up here, shows up here, and then it shows up in the denominator. That's just something I always remember, that the condition that we sent shows up in every piece of the equation. I don't know if that helps. If it does, then you should use it. So we know the probability that they both happen at the same time. That's that 42%, 0.42. We know the probability that they have a meal program, 0.62. We don't have to do anything where we subtract 0.62 minus 0.42 like when we made the Venn diagram. It's just the entire percentage of students who have a meal program. And so we get a probability of 0.6774, or a 67.74% chance that this person we're talking to in a campus dining hall also lives on campus. So let me do one more. So here we have a table that is comparing the gender of students, and then what is their most important goal, I believe, in high school. Elementary school. And so we want to know the probability if we randomly select one of these 478 students, and we know that they're a girl, so we're only randomly selecting actually from the girls, the 251 girls. We want to know the probability that the most important thing to them would be to be good at sports. And so we can set up our probability statement. We want to know the probability their favorite thing is sports, given that they are a girl. And so we are going to need the probability from our table that they're a girl and they are most interested in sports. And we'll divide by the probability that they are a girl in general from our group of students. So the probability that this randomly selects a student is a girl and is most interested in sports is this value here, this 30 out of 478. And the probability of being a girl would be the total 251 girls out of all of the students. And so if we do that calculation, we get a value of 0.1196. So that is the probability that the most important thing or their goal in school is to be good at sports if we already know that the student is a girl. So one thing we can use when we have a conditional probability is we can use it to decide if two events are independent. And so here is the conditional probability statement that we have from earlier. And so if the conditional probability of B happening, given that A already happened, is the same as the probability of B happening to begin with, so that means event A happening doesn't affect or change the probability of event B happening. If those two things are the same, then that means that those two events are independent. They don't change each other's probabilities. That means they're independent of each other. We talked about being disjoint in the last lesson. That means the two things can't happen at the same time. And it's important to note that two events can be independent or disjoint, but they can never be both. It's possible that they're neither, but they can never be both independent and disjoint. Just kind of a small note there that is not so small in importance, something we need to know. So we've talked about what it means to be disjoint. The other thing we called that was mutually exclusive. That would be a Venn diagram where the two circles don't overlap. So they can be independent, they can be disjoint or mutually exclusive, but they cannot be both of the two, and it is possible that they are neither. So again, if we go back to our meal program, we want to know if living on campus and having a meal plan are independent of each other. And so what we need to know is the probability of living on campus given you have a meal program equal to the probability that you live on campus in general? And so we found this first probability at the beginning. And I'm going to put a little question mark right here because we don't know if they're equal. The probability of living on campus given that you have a meal program is 0.6774. We just calculated that earlier. And we're told that the probability of living on campus, or the percentage of students who live on campus, is 0.56. And I think we can see pretty quickly that those two numbers are not the same. They're not equal. That means that these two events are not independent. That means that there is some relationship between living on campus and having a meal program. And that might make sense to you that you're more likely to have a meal program if you live on campus. But we are using our data to show that there is some relationship. We don't necessarily know that one causes the other, but we know that there's a relationship. We know that the probabilities are not the same, and so they're not independent. What's also true is that they are not disjoints. And we know that from our last lesson because when we drew a Venn diagram, there was an overlap. 42% of these students live on campus and have a meal program, and so they can happen at the same time. So these events are neither independent or disjoint. Let's talk about one more of those. Back to our children in school and their preferences. We want to know if having good grades and gender are independent. So we're going to go ahead and since we were talking about the girls before, we'll talk about them again. We'll see if the probability of grades being the most important given you are a girl is the same as the probability that grades are the most important thing in general. And so we can find this probability by taking the probability of grades being the most important and being a girl, that 130 divided by 478. And we'll divide that by the probability of being a girl, which um, we found earlier, but we can find again, 251 over 478. That's going to give us this conditional probability. And then the probability of grades being the most important to you is that 247 over 478. I'll put a question mark there for now because that's what we're trying to figure out. Are they equal? When we make these calculations, these two numbers are not exactly the same, but let's be real. They're both approximately 51 if we round 52%. So they are approximately the same. So we are going to say they are the same. And we're going to say that these two things are independent. And so what that means for us is based on our information, based on this group of students, gender and grades being most important are independent. That means one is not influencing the other. The probability is not changing when we just look at girls. So the probability of grades being the most important thing is almost exactly the same for the whole group as it is when we set the condition that our student is a girl. So I have a few questions here about conditional probability and independence. So there are 5 based on this problem, and there's 5 based on the second problem. Make sure you answer all the questions. If you do need help, as always, please make sure that you ask me for help. I'll be glad to work with you. Take your time on these. Good luck.